All right. So good afternoon, everyone. Welcome to the Watershed Forest Management Long-Term Protection through Resistance and Resilience breakout session. Really thrilled you're all here this afternoon. And before I dive on in and kick it off to Don, just a couple housekeeping reminders. John Parke is joining us, just as a flag for you, Don, too. So
Okay.
Yep. So housekeeping, this session is being recorded and will be shared on the Coalition's YouTube channel early next week. So we'll be sure to send that link and all the links out to you in case you missed something that you wanted to hop on. Please keep yourself on mute unless you're speaking. Given we have a relatively, small enough crowd, we have about 26 folks, 28 folks now. Feel free to take yourself off mute during the Q&A session. We can play that by ear, but, definitely want to have a conversation at the very end. If you're having any technical issues, feel free to directly chat me in the chat box. I'll do my best to try to help you out. And with no further ado, John Parke, I will kick it off to you if you're all set up.
Yep, all set.
Excellent.
Okay. Hi, everybody. John Parke, Stewardship Project Director for New Jersey Audubon. So today's presentation, so we all recognize that forests have been proven to be among the most effective cover types for filtering water and for watershed protection. And today, almost all of our forests that we have throughout the northeastern U.S. have been regrown in response to human influences on the land and settlement patterns over the past 100 years, making them somewhat simplistic in structure, composition, and age. And that homogeneous nature of the forest makes them more susceptible to other stressors like climate change and the introduction of non-native pests and diseases, which, can ultimately compromise sustainability and watershed protection and other ecosystem services. And in response to society's increased needs from forests, the science of forest management has evolved during the past 25 or so years, using forestry as more of a tool to increase biodiversity and complexity and sustainability, water quality improvements. It's just not just about wood production, as a lot of folks think it is. And with that in mind, in today's session, we're going to be looking at how land managers in the Quabbin Reservoir system are using forestry to help sustain that water supply that serves communities in the Boston area. And that work done at Quabbin, which includes long-term monitoring and can serve as a demonstration of transferable and scalable actions that landowners in the Delaware River watershed can take and make a positive impact on water quality. So this talk will more or less describe the variety of those programs that Dan and Brian use to support their mission that includes land protection and active management of forested, non-forested areas. So with that, I'm going to introduce our two speakers. First up, we have Dr. Dan Clark. Dan serves as the Regional Director of the Massachusetts Department of Conservation and Recreation. It's a division of water supply protection in the Quabbin-Ware River region. The division's mission is to provide clean drinking water to over 3 million customers in Massachusetts through careful watershed protection, planning, and management. Dan's been serving with the agency since 1995 and was originally hired as the conservation biologist. And since that time, Dan's career over at DCR has been involved in a variety of wildlife and forest management projects, including white-tailed deer management at Quabbin and the development of the regular land management plans. We also have with him today Brian Keevan, and Brian serves as the forest management specialist with the natural resource team of the division, and his responsibilities go across all the DWSP watershed lands. Brian joined the natural resource section in 2014 as a management forester, but now he oversees and reviews the compliance of all division forest management projects within the LMP. He also oversees all the data collection and analysis of the division's continuous forest inventory and all the terrestrial invasive species monitoring and controls. With that, I welcome Dan Clark to take over.
Well, hello, good afternoon, everybody. It's a real pleasure to be here, sort of share
some of our projects and work we've been doing over the last several decades. So as was mentioned, we're going to talk today about Boston's water supply. It is a system. So as you can see from this map, it's a connection of 3 active watersheds, 2 active reservoirs. There's actually a 3rd reservoir that's not active at this part, but it is part of the system. And this system delivers water to over 3 million people every day in 51 communities scattered throughout metropolitan Boston and a few in Western Mass. The system itself can maintain a safe yield of about 300 million gallons a day. What distinguishes this system from a lot of other systems the same size is that it's treated, but it's unfiltered. So typically when you have a system this large, there's a filtration plant. We don't have that. We have a treatment. So we do some treatment with ozone, chlorine, we adjust the pH, and then we add a little fluoride at the end. Next slide, please. So before I jump into what we currently do, I thought I'd provide just a short history of Boston's water. It's actually a really fascinating story, sort of Boston's continual quest to satisfy its quench for drinking water. And it began a long time ago. So in 1795, they developed the first public water supply, Jamaica Pond, just to the west of Boston. In 1848, they needed more water and they brought Lake Cochituate online. It's in Framingham, a little further west. That didn't last long either. In 1870, they built a new reservoir, Sudbury. They dammed up the Sudbury River and created the Sudbury Reservoir. You could see that lasted about the same period of time. So further west, they created Watershed Reservoir in the early turn of the 20th century. At the time, it was actually one of the largest reservoirs in the world. Next slide, please. So even that wasn't enough, and they looked even further west and established the creation of Quabbin Reservoir in the 1930s. And this was a significant undertaking. There were actually 4 towns that were in the footprint of the reservoir. They had to be disincorporated. Everything moved out. Next slide, please. So these slides sort of give you a visualization of just how extensive this project was. So the upper left is a church in one of these 4 towns, pre-Quabbin construction. And then you can see in the upper right, the actual construction of Quabbin. So they stripped everything bare, all the vegetation, all the buildings, all the cemeteries had to be moved. You can see the church was one of the last things that they took down. And the bottom 2 represent the same location over different periods of time. That's Dana Center on the left, what it looked like in the 1920s, and then Dana Center, what it looks like today. So a real significant achievement, I think, but also a significant amount of work went into creating this system. Next slide, please. So I'm going to briefly walk through what each of the watersheds look like, some of the characteristics. We won't spend a lot of time on this. So the further east, Sudbury, I mentioned this is our emergency backup supply. It's not an active part of the system. You can see we own relatively little amount of land right around the reservoir. Very little of the land in the watershed is protected. Next slide. Moving west, Watershed Reservoir. This is our terminal reservoir. This is where the water leaves and enters into the distribution system. You can see it has a little more protection, either by our ownership or other protected land. It is primarily forested. And this sits in the sort of the outer suburbs of Boston. Next slide. Sandwiched between Quabbin and Watershed Reservoir is the Ware River watershed. There's no reservoir in this watershed, but we do use the water from the Ware River. We can divert it, actually either to Quabbin or Watershed. We almost always divert it to Quabbin. And you can see we own even more land in this watershed and other protected land, and about the same amount of the area is forested. Next slide. And then finally is Quabbin watershed, which is our largest watershed, the largest reservoir as well. And you can see that we own a significant amount of this watershed. I think they sort of lessons learned as they continue to develop these watersheds over time, that they realized they probably should buy more and more of the land around the watersheds for long-term protection. So you can see combined, the majority of this watershed is protected, and it's a high percentage of forested land as well. Next slide. So I do want to talk about our land acquisition program. We have a very aggressive program that's been going on for several decades now. Started in the 80s. We do our purchases directly, outright purchases through fee, or we establish these watershed preservation restrictions. That's really just our name for a conservation easement. Basically, we buy the development rights, but don't take ownership of the property. Our land acquisition is really focused on Quabbin and Wachusett. We don't buy much land in the Ware River. Through 2017, we've spent about $135 million. Most of this funded by the Massachusetts Water Resource Authority. They are a partner, so they are responsible for delivery of the water after it leaves the reservoir, and they are our main funding source. So the ratepayers pay them to beret, and then they support our budget. Next slide, please. So these next two slides visually represent the achievements of our land acquisition program. So this is what we own just as the land acquisition program was started in 1985. The most striking thing you can see in the Wachusett watershed, we own very little land, basically what's around the reservoir. And again, a little more in the Ware River, and we made significant improvements at the Quabbin. If you go a slide forward, this is what we have in acquisitions to the present day. So the green is the land we own, and all the orange are those restrictions or easements. So if you sort of toggle quickly back and forth, you can see we've actually picked up a fairly significant amount of land. In 1985, we owned about 86,000 acres total across all the watersheds, which is about 38% of the watersheds. Today, we own about 104,000 acres of land and another almost 9,000 in restrictions. And we have control of about 50% of the watershed now, either directly or indirectly. So it's a fairly significant jump over the last 30 years or so. Next slide. So to sort of set the stage of what we're going to be talking about for the rest of the presentation, the watershed, the agency, the division does a lot of planning, does a lot of reports. We generate a lot of information, and we use this information both as a way to present what we're doing to the public, but also as guiding documents to really direct how we manage the land, how we manage public access, what are we doing for long-term watershed protection. So all these plans, actually, I think they're all available online now, so people can take a look at them and see what we're doing. Next slide. So I'll be honest, this is the part where Brian is supposed to take over. I don't know if Brian made it onto the Zoom. He was having trouble.
I'm here. Can you hear me?
Oh, fantastic. Awesome.
Yeah.
Brian's there. Go ahead, Brian.
Well, yes, thank you for letting me join here. So John alluded to this in his introduction, but I figured I'd briefly go through sort of the background of New England land use history here. These are slides downloaded from Harvard Forest. If you ever get a chance to get up to Petersham, Massachusetts, I strongly encourage you to go to the Fisher Museum and see these dioramas. That's where these images come from. These are actually meticulously crafted little displays of what forest history was like. This is an image of what pre-colonial forests were looking like. Mixed late successional species, a lot more hemlock, oak, beech. Next slide, please. Over the course of the following maybe 200 years into the middle of the 1800s, European colonial settlers basically cleared all that away and created the agricultural viewscape you see here. The peak of that was the mid-1800s, when about 60–80% of New England was probably deforested. Next slide, please. As As circumstances changed, better farmland was found out west. This is probably not news to any of you. The farmlands in New England were abandoned and started to revert back to forest. White pines were a significant component of those regrowing fields and became a significant timber, contributed significantly to the timber volume that was harvested. Next slide, please. Towards the end of the 1800s and the beginning of the 20th century. So we still have a portion of those pines, but mostly what we have on Quabbin and to some extent all around southern New England are the hardwoods that sprouted up following the white pine removals in the early part of the 20th century. Next slide, please. When the Wachusett was first being proposed and built in the late 1890s, they acquired a bunch of land around where the reservoir was going to be, and it was still abandoned farmland and active farmland at the time. So there was already considerable knowledge that tree cover was best for water supply lands, and it held the soil in place better. So what did we do but sort of import the European model of tree growing, which was conifer plantations, and hired dozens and dozens of people to establish nurseries throughout the watershed and plant out millions of pine trees, and starting from really about 1902, 03, I think, are our earliest plantations at Wachusett. That continued all the way through the 1940s at Wachusett and out at Quabbin too. Next slide. We see some evidence of that still today in the amount of pine cover resulting from those plantations, and also the continued abandonment of farmlands in the early part of the 20th century. You look at the various distributions of cover types, the hardwood types sort of on the top of these stacks and the softwood types on the bottom of these stacks. So there's still quite a significant amount of pine, but hardwoods, especially at Quabbin, dominate over half of the forest. Next slide, please. The age structure is something that was alluded to by John and is of interest to us. In early land management plans I was reading through yesterday, they do emphasize the fact that our forests are pretty even aged, and it's not like they're all the exact same age, but there are large blocks of fairly uniform age classes. This is a pie chart that I put together a number of years back looking at Wachusett, and these are just the lands that DCR owns at Wachusett. You can kind of see that we have, almost a quarter of the forest there is well over 100 years old, dating back into the last quarter of the 1800s, and significant portions date to around 1900 to 1920, and a big portion, at least at Wachusett, can be dated back to a 1938 hurricane. That's that 61 to 80 year block. And then you see up in the upper right quadrant, sort of we're starting to break up that pie a little bit, and some of that is related to our forest management. Some of it's related to acquisitions, acquiring new farmlands that are now regrowing forest, and some of it, like I say, is related to silviculture. The Quabbin watershed is very similar to this, probably even less so to, or less young forest at the Quabbin right now. Next slide, please. So why are we so interested in forests? Certainly it was alluded to before. We rely on this continuous forest cover throughout the Quabbin, Ware River, and Wachusett watersheds to essentially filter the water at the source as it's getting into the reservoirs. And there's plenty of science that really isn't in dispute about why forests do a pretty good job at this. They intercept rainfall, reduce that erosional force onto the soil. Young trees rapidly growing take up a lot of nutrients and remove that from the surface water. The surface litter itself builds up a nice organic layer and retains sediments on site and keeps the surface waters flowing clear and cool. Next slide, please. So we've got a long history at all these watersheds of harvesting the trees that we grow. Yes, forests are certainly primary for water filters for us, but you know it seems odd that we would also cut those trees down. So we do have certainly a tradition in New England and throughout the Northeast of harvesting trees, make the land productive. You can see that just in the agricultural slide we saw before. And in the forest cutting history throughout the area. It was the exploitive cutting of those pines back in the early part of the 20th century that prompted a lot of the legislation and creation of state forest lands. So that was happening about the same time as these public lands were being acquired for watershed protection, and a lot of what we were doing here was prompted by what was happening there, a sense that we needed a publicly owned, dependable source of local wood products. I mean, of course, this was 100 years ago, so things have changed significantly since then, but that was the thinking back then, and it still drives some of what we do today. Could I have the next slide, please? So certainly the reasons that we began harvesting those trees back when they were maturing involved the investments that we'd already made in those plantations, the desire to make sure that the plantations were growing a good quality timber crop and something that we could capitalize on. We hired professional foresters beginning in the 1960s, starting at Quabbin and gradually working their way, acquiring forestry staff further east in the watersheds. But Quabbin was the first place we had sort of modern forest management. And I think the land managers at the time needed somebody in there who knew what to do with all the forests that we had, especially those plantation forests. So the foresters came up with a plan to measure the forests in the watersheds and manage those plantations. It was interesting to read through the land management plans from the 60s, 70s, and 80s. And the goals certainly have changed over the past several decades. Back in the 1972 Forest Management Plan, there was a very strong stance on needing to reduce forest cover, almost permanently reduce forest cover, to maintain and increase water yield coming from the watershed lands. This was prompted by significant drought periods in the 60s and early 70s, especially at Quabbin, where the water levels were way, way down from where they are kept at today. Those yield needs, those yield desires, were also prompted by problems within the distribution system in Boston. Those old systems were very leaky, and we were probably sending a lot more water into the city than we needed to. So with the detection of those leaks, repairs of those leaks, by the 1990s, the shift in focus from water yield, we shifted focus over to looking at water quality. We didn't want to certainly reduce water yields, but we were looking more at the importance of forests in maintaining water quality. Next slide, please. And where we're at today, looking at our management plan now, we're looking at the idea of resiliency in the face of all sorts of natural disturbances. We have major windstorms like the 1938 hurricane, which is big here in New England. I'm not sure if anybody else knows about that, but that was a major disruptive force here, and it seems that the periodicity for large-scale wind disturbances is on the order of about once a century, which means we have a disturbance adapted forest here. So it's unpredictable. We never know when those things are going to come. We never know how big the impact is going to be. So what do we do about that? Well, we try and think about building in a bit of resilience to our forest. In the way we do that is to control that distribution of risk over area and time by deliberately patterning disturbances through the use of silvicultural methods, breaking up the sort of monotonous, even canopy into a mosaic of younger, middle-aged, and older patches of canopy, while also allowing for a diversity of tree species native to the area. These practices, we'll get into what that looks like on the ground in a minute here, but they're not only we're not only able to contribute to the local economy, but these patches are extremely beneficial for local wildlife habitat needs. I'll take the next slide, please. So just give you a sense of sort of the extent of forestry work that's taken place over the years. So this is the land ownership, the DWSP land ownership in fee around the Quabbin Reservoir. And if we take the next slide, you can see that over the last 60 years or so, we've actually, now this isn't like places we've cleared. This is places where we've done a little thinning or done some patch cutting, or so there's a lot of different activities gone over here, and they're kind of broken up decade by decade into these color classes. But we've actually had a hand in managing a vast majority of the properties that we own. You saw a picture I showed earlier on about forest filtration. When you look out across the watershed, it looks pretty near covered in forest. So what we're doing here is we're a long period of tending that forest, and now we're into sort of a regenerating phase of that forest. You'll also notice on this map there are some areas with almost nothing happening. Obviously we can't get to the islands. It looks like at some point, maybe when there was a drought year, we were able to get out to one of the islands and do a little tending and cordwood thinning out there. But we do have some set aside areas, steep areas, wetlands, riparian zones, and some reserves over on the east side of the reservoir and down around what we call the Quabbin Parke at the south end of the reservoir. Next slide. So what does it look like on the ground? Our typical silvicultural approach at this point is to manage about 3/4 of all of the forested acres we own. Like I say, about 25% is split up between designated reserve areas, inaccessible areas, wetlands, that kind of thing. And we're looking at a natural disturbance impact of on the order of about 1 to 2% on average a year, natural background. So we're trying to mimic that with our deliberate patterning of disturbances. We've shifted away from what I would call even age management, where stands are tended as large blocks, 30, 40, 50 acre blocks, evenly thinned, evenly regenerated, and the idea at that point would be evenly remove the cover. We've shifted away from that in recent decades to more of an extended, that's called a shelter wood, where you let the regeneration grow up underneath the overstory, and then you take the overstory off and let the young trees grow. We're sort of extending that shelter wood, but doing it in patches. So in any one area, we're not taking off the entire overstory at one time, but we're doing it in small patches that range in size. They're variable in size and shape. We try to fit them to the landscape. And within those patches, we don't always take all the trees down. In fact, most of the time, we're not taking all the trees down. There's young trees that are left, when possible, and older trees that are left for structure, for old growth characteristics, for future coarse woody debris, seed sources, that kind of thing. The last bullet I have here is intermediate mid-rotation harvests. We're probably a generation of foresters away from needing to do a lot of that kind of work. The first generation of foresters were tending young stands, post-hurricane stands, young plantations. The regenerated patches we're creating now are going to need another 20 or 30 years before those patches would be tended to promote better species diversity, remove poor quality material, create a more desirable, healthier forest canopy for watershed protection. Next slide, please. So planning constraints when we're doing forest management. We certainly have, in Massachusetts anyway, I can't speak to the rest of the states who might be represented here, but we do have pretty good cutting practices regulations. in Massachusetts. They require volumes to be recorded and posted, water quality standards to be met, silviculture to be explained, and regeneration of young trees to be accounted for as part of that plan. So there's a branch of DCR that oversees all that, and our branch of DCR, the water supply branches, is subject to those regulations as well. So in addition to the legal side of things, we certainly are interested in anything we can do to maintain high quality water coming off of our watersheds. So we have pretty strict internal constraints on riparian zone work, and especially reservoir filters and wetlands. We don't operate in areas where we shouldn't be. Wetlands are supremely important for, I would say, flattening the hydrograph on storm events. They act as a good sponge. This is probably all stuff that's been talked about in other parts of this workshop, but so we certainly are very keen on protecting water quality. Minimizing soil damage, it's, we're putting big equipment out there in the woods to remove these trees. And it's tough to make sure that that is done correctly. So it's the foresters that we employ are all licensed foresters. The loggers are licensed harvesters, and the skid trails are laid out deliberately by foresters to avoid sensitive areas. Stream crossings are minimized to the extent possible, and where they are necessary to access the properties, impacts to the banks and the stream side buffers are mitigated with a variety of measures. The next bullet is 25% threshold. The literature seems pretty clear that the more wood you take out of any sub watershed, any watershed, no matter what size, but the more volume, more stocking of trees you remove, the greater the impact to water quality and water yield. So our planning includes sort of a GIS exercise with almost every timber sale we do, which involves making sure that we don't exceed a threshold of about 25% stocking removal per sub watershed over any 10-year period. That gives those areas that have had their trees removed time to regenerate, regrow, and begin the process again of retaining those nutrients and forming that good that forest cover that protects water quality. Our overall removal rate is about half of the rate of wood that we're the rate of biomass that we're growing on the landscape. So we're definitely operating at a sustainable level, and we are creating species diversity and structural diversity through our actions. I talked a little bit about old growth characteristics, but we have certainly set aside reserve areas, inaccessible areas, and then sort of what we call little pocket reserves. These are places where, for whatever reason, foresters aren't likely to manage or deliberately aren't managing within any area that they are actively managing. Would it be possible to not see the chats coming up in my window? That'd be great. Providing young forest and focus areas. We, with our latest land management plan, we recognize the fact that we are the largest landowner in central Massachusetts. We have over 100-something thousand acres of property in a big continuous blocks. And most of that is mature forest. There are species in decline in Massachusetts related to young forest habitats. So we designated certain small blocks where we would do slightly larger openings, 10 to 15 acre openings, stuff more like what forest management looks like in other parts of the country, but just to maintain habitat chunks big enough to support species in decline and species in peril in Massachusetts. Next slide, please. So here's, sorry, it's an older slide. I didn't take this picture. It probably goes back about 20 years, but we were looking at, oh no, 1996, okay. So we're looking at sort of what forestry at the Quabbin can look like on the ground. This is a half an acre opening. Like I said, openings vary in size, but here's one where about a half acre was taken down and without canopy retention. Take the next slide, please. And here it is only 5 years later. We see ample regeneration coming back, not only from stump sprouts, but from seedlings too. Next slide, please. And by 11 years post-harvest, we're looking at something that already is beginning to look like young forest. We certainly have a canopy intact, even though it's shorter than the surrounding canopy. It's an intact young canopy. The leaf litter layer is intact. So we certainly see that the trees regenerate well in our properties. Next slide, please. Talked about green retention. Various ways to look at green retention. We're looking at young trees, pole-sized trees, and mature trees, providing some of those benefits: additional shading, seed sources, habitat value, and just sort of to break it up. We're not immune to the concerns about aesthetics. So these kinds of things certainly are a little bit more attractive to the person, there's a casual observer, than just a wall-to-wall tree removal. Next slide, please. Standard practices for water supply, well, for forestry in general, are to protect water quality in this state. But we go a little bit over and above on our stream crossings, where we're bridging them, I think more frequently than might be happening elsewhere. We are expanding the width of filter strips, which are those streamside buffers, depending on soil type, depending on slope, erodibility. We require things like spill kits in equipment and at landings. And we have our foresters who are out there inspecting all the time. And we'll shut things down if they're not looking good and make things get cleaned up. And to enforce that, we include performance bonds as standard in our harvesting permits. Next slide. So public lands forestry is certainly controversial. There's always challenges to what we're doing. We think we've got a good justification and rationale for the kind of work we're doing, but there is certainly a commercial harvesting stigma of doing this kind of work where loggers come in to harvest wood off public lands. There seems to be the ability to use social media to, sometimes it's misinformation, sometimes it's just exaggeration, but the idea that any kind of tree cutting is almost falsely equivalent to clear cutting and bad practice. We see that a lot, and it's out there. It's hard for us to always counter that. We're a public agency, there's limits on how much we can get involved in controversies. In the next bullet, I talk about the legislation efforts to cease management. It's pretty much always here. There's always folks who think that all public lands cutting should cease. We certainly don't support that. We think we've got a good program, and we think we have a reason to continue to manage for multiple benefits while still taking wood off the property. Next slide, please. But we're not alone in our thinking. We actually do include others in the oversight and review of our overall program and our sort of fine-grained part of the program too. So there is a Science and Technical Advisory Committee that for a number of years looked at various issues associated with water supply forestry. They did a review of our program about a decade or so ago, supported it, encouraged us to do a lot more public outreach and public review, which we've incorporated. We post all of our timber sales, all of our lot proposals out on our websites. Our land management plan was recently updated. We're about 2.5 years into it now. It will be updated again in 10 years, well, at a 10-year mark. We had been developing individual watershed specific land management plans until now. We finally decided to incorporate all of our policies and all of our land management planning into one watershed, one division-wide document. So that was publicly viewed and vetted. We received comments, and we think that we generally have, although not everybody agrees, but at least we think we have a good handle on the public appreciation for what we do. At a fine grain level, internally, every year we're looking at all of our proposed timber projects for compliance with our land management planning, for silvicultural work, for wildlife impacts. Certainly the water quality engineers are interested in what the foresters are out there doing, and they take a look at everything that's going on. And then the state archaeologist, or at least DCR's archaeologist, has recommendations every year for how to protect historic and pre-contact cultural resources. And all of this stuff, like I said before, is posted on the internet. Next slide, please. We monitor what we do. There's a lot of different kinds of monitoring that goes on out there. Regeneration in young patches like this. We look at after a period of time since post-harvest. We've been doing this since the late 1980s in response to some major concerns about herbivore pressure on our young forest. We look at invasive plants as well. Next slide, please. We also have a continuous forest inventory project that every 10 years we return to permanent plots throughout the Quabbin and Ware River watersheds. We have permanently marked trees. We measure the diameters and heights of those trees. We try to get a sense of growth, volume growth, species composition, species mortality, and changes over time. We're looking at stocking of biomass. And certainly, as we move into the 21st century, carbon stocking levels are certainly of huge interest. And this project will help inform what the public knows about what's happening on our watersheds. Next slide. Oh, and speaking of which, the CFI numbers do indicate that over the last, looks like 50 years, we've had a steady permanent or a steady increase in the amount of above ground live stocking on our properties, despite the fact that we've done all this harvesting over the years. I guess that's all I have to say on that one. Yeah, we can move on from this one. Another, so since we're a water quality agency, we do have a huge interest in water coming off of our forested areas and how our work is impacting that. There's a lot of literature out there about how forestry can, or how changes in forests can affect water. So we're actually in the middle of a paired watershed study. We have two of them going on, one here at Quabbin. You can see the two sub-watersheds there. There's another one going on at Wachusett, where we're doing a paired watershed study with a treatment versus control, looking at our typical management, the kind of stuff I was already describing to you. And we'll be monitoring for impacts to yield and quality as the treatment watersheds are harvested, and then for a number of years after as they regenerate. Next slide. Oh, I think Dan was going to pick this one up.
Thanks, Brian. So a big part of our story is a discussion, I'll try and keep it relatively brief, on herbivores. So if you're a forest owner, and this can really apply at any scale, if you want to keep and continue to have forest on your property, you have to be assured that the forest is regenerating or has the ability to regenerate and produce new trees. And one of the potential impacts on the ability of a forest to regenerate is pressure and browse pressure by herbivores. So the history of Quabbin, so when Quabbin was created in the 1930s, it was actually shut down to all types of hunting, including white-tailed deer. And basically for the next 50 years, there was no hunting mortality at Quabbin. And the result of that, and this has actually been shown in lots of other areas around the country, that without the absence of this type of mortality, deer populations can respond tremendously. So at Quabbin, we had deer densities of 40, 50, 60, maybe even higher deer per square mile. At that level, forest regeneration is severely limited. Basically, the deer eat everything that pops up and tries to grow in the ground. And what you're left with, in most cases, is things that deer won't eat. And in New England, a lot of that is ferns. And in a lot of cases where there's invasives present, you'll see that as well. And what happens is, as your mature forest declines, there's nothing to take the place of it. And the long-term sustainability of the forest becomes a question mark. Next slide. So DCR's response in the case of Quabbin was to institute some deer management. And this started as a process. So in the late 1980s, we really went out and started collecting a lot of information, both on the deer population, but also what was going on in the forest. What kind of regeneration did we actually have? We set up some exclosures. These really provided a handy visual representation of what was going on. So inside a deer-proof fence, this is what the forest would look like. Outside the deer-proof fence, this is what you're left with. That's that bottom graphic where you can see that stark difference between inside and outside the fence. There was controversy in this as well. The court case that tried to stop the hunting, ultimately DCR was successful. We continued, and we had our first controlled hunt in 1991. And we have been managing deer at Quabbin in some fashion ever since 91. Next slide. So the results of this deer management have actually been really, really successful in terms of reducing deer densities and subsequently reducing impacts of deer densities on forest regeneration. So you look in the early years of the hunt, 91 through 95, 96, you can see we harvested quite a few deer. So if you look at this graph, on the bottom axis is the year, on the x-axis is deer density estimates and deer per square mile, and on the z-axis is our harvest, the actual number of deer harvested. You can also see that in a relatively short period of time, we were able to substantially reduce deer densities and maintain them at a relatively low level where forest regeneration was possible. Next slide. What was the result from the forest? Well, you can see by this graph, so in 1989, this is before any deer management started, you see these two bars representing forest regeneration. So total regeneration, then we have the green bar represents regeneration above 4.5 feet. This is a critical number. This is the point at which the regeneration gets up beyond the reach of a deer, and you can fairly safely assume it will make it into the understory and the overstory. So over time, a significant increase in the total amount of regeneration we find at Quabbin, and also that critical 4.5 feet as well. Next slide. So while the total regeneration we've really transformed the forest in terms of how many young trees are out there, we are still struggling with diversity of the tree species. So to represent that, we have this pie chart from 1970. This is using our CFI data. So these bar pie slices represent the percentage of those species that were essentially recruited and then were able to be counted in the CFI in 1970. So these species were probably regenerating, in the 1940s or so. You can see we have 7 species that sort of co-dominate this pie graph, including several oak species. Next slide. When we look at the data from 2010, so after many, many decades of sustained high deer densities, what we see is that the number of species being recruited has gone down, and it's really dominated by basically 3 species: white pine, red maple, and black birch. By no coincidence, these are also 3 species that are very, very low preference species for deer to browse on. So even though we've made tremendous strides in the number of trees we can regenerate, we still have a long way to go. Well, we have a ways to go to really bring back that diversity. I think it really sort of speaks to the, the legacy of sustained high deer populations and what it takes to sort of overcome that legacy. Next slide. I will talk briefly about moose, just one slide. I suspect most of you are beyond the southern edge of the moose's range. We do have moose in Massachusetts, believe it or not. They came to the state on their own in the late 1980s. Not surprising, given the land ownership of DCR. We have some of the largest contiguous land in the state. Really, the core populations in the state are at Quabbin in the Ware River. And why are we concerned? Well, it's another herbivore. And in fact, it can consume, up to 10 times the amount of food per day that a deer can. So we have a lot invested in this forest regeneration, and we want to make sure we continue to be successful. And if there's a potential that moose might influence our success. But the reality is, in Massachusetts, the moose is protected. There is no hunting season. They're not considered a game species. So what we do right now is really just sort of monitor moose populations and potential impacts. So we do a variety of surveys, pellet surveys. We have some long-term studies on exclosures. We do some moose sighting surveys to really sort of document what we think the potential impact from moose could be or might be in the future. Next slide. Back over to Brian.
Thanks, Dan. All right, so yeah, now we get into one of the hardest things that we have to deal with, I think, going forward is going to be terrestrial invasive plants. These things have been nothing but a headache for us. They result from the globalization of our economy, our land use history, and any kind of disturbance to our water supply lands. Deer certainly exacerbated the problem, and they by preferentially browsing out a whole bunch of our desirable tree species, they made room for invasive species. Like here we see some bittersweet. We have a lot of Japanese barberry, knotweed. Basically you name the invasive species, we have it somewhere on our water supply lands. Ferns as well. They act just as invasively here because of the high deer numbers. Our forest is going to struggle to regenerate despite all of the work we're doing without some way to deal with the invasive plant problem. So we have a strategy in place. It's been in place for about a decade now. We're in the process of updating that. But if you go to the next slide, we could talk about some of the ways in which we're doing some invasive plant control now. These efforts are limited in our initial go at this. We don't have a big budget. We don't have sort of a big push for this yet. It's coming, but right now we're targeting our efforts to things like habitat restoration. This was a before and after picture of a place that we affectionately call the Olive Garden. It was a piece of mass highway surplus land in the town of Holden, Massachusetts, that was basically almost wall to wall autumn olive. So we tried to restore that so we can get some trees growing back in there. We started with mechanical controls, as you can see in the bottom slide or the bottom picture. We purchased a couple of skid steers with mulching heads so that we can start mechanically working on some of these problems, and with the hope that they can be followed up with some sort of chemical, if possible, to on a much lower extent than would be needed to treat them in the first phase. So next slide, please. There's Dan from about 2003 out on a rare plant location somewhere secret in Quabbin, where we have something interesting growing in among those talus slopes there. And Dan is part of a group of folks hand pulling some looks like bittersweet out of that area there, just to create sort of a protected buffer around rare plants. And this has been done in a few instances around Quabbin, and let's see, where's the latest one? Yeah, at Quabbin. We have another focus is early detection species, early detection rapid response, EDRR. species that are just coming into our area, like mile a minute, Japanese stiltgrass. Here's a habitat restoration field where we were trying to restore this to a grassland habitat for bird species production. And it's infested heavily with Canada thistle, which isn't even really a thing in this state yet, but I know it's a huge problem in other parts of the country. We're trying to deal with it through a combination of mowing, some chemical treatments. We're trying to make this problem go away before it gets spread around all over the water supply lands. Next slide, please. And then within our forestry program, we actually we inspect equipment coming into the jobs so that they're not bringing in mud, or they're not leaving with mud on the tires and potentially spreading invasive plant propagules from our properties off and from off properties on. So our foresters check every piece of equipment that comes on the property. Next slide. So where are we going from here with invasive plant control? Well, like I said, we're trying to develop a new terrestrial invasive plant management plan. As part of that, we will be enlisting the aid of our Science and Technical Advisory Committee to give us some guidance. And of course, we'll be presenting that for public input, you know, as we get further down the road with that plan. Part of that plan will involve more extensive surveys, and then we're going to have to address how we deal with invasive plants out in general forested settings. Do we do that as part of harvesting permits? Is it contracted work that happens otherwise? There's a lot to talk about. Budgeting concerns. This doesn't bring any money in, so it's a lot of money going out. It's going to require staff. So anyway, it's a big topic, and we're getting there. Next slide, please. And I think, Dan, you're going to take this.
Sure, just to try, this is our last slide, so just try to wrap up some final thoughts and maybe make it a little more relevant to some private land owners or people responsible for smaller tracts. So we do think our framework can be applied at many different scales. I mean, we have 100,000 acres, but there's no reason why these approaches or programs can't be applied at a smaller scale. You know, part of that consideration is, you know, long-term multi-odor planning. So a lot of these things take time. You know, forest doesn't happen overnight. A lot of the things that you might be trying to achieve might take you, you know, decades to get where you need to be. And we feel strongly that this active forest management can not just maintain ecosystem services, but in many, many cases enhance ecosystem services. And again, diversity at lots of different scales, we believe strongly can make improvements to everything. Wildlife habitats, you know, climate change, long-term sustainability of lots of things. And then the final thought is that there are some local economic benefits. So I don't think you should shy away. You know, trees are a renewable resource. We all use wood products. I don't think anyone could say with a straight face that they don't use wood products. And when approached the right way, you know, forest management can provide some sort of economic benefit in addition to providing all these other benefits as well. I think that's all we have.
All right, well, thank you both for the detailed presentation. I know the chat box is quite full, but, you know, in the interest of time, if anyone else has any specific questions for the presenters, by all means, feel free to take yourself off mute and ask the question directly.
I have a question. Can you hear me, Sandra?
Yep. Yes.
This would be either for Brian or Dan, and maybe it's too long of an answer for this forum, but do you have any information? I know you talked about some of the paired monitoring studies. Do you have any past information on some of the soil chemistry, water chemistry issues that may have been looked at in the past from the harvesting programs?
Let Brian.
Basically I guess you're thinking about from these same studies or from other studies?
Well, it wasn't clear how long those studies have been in place. Is it an ongoing study, or do you have some prior studies that you have information from?
There is a prior study that was published, I think the American Water Works Association funded it in maybe 2004, that was looking at different land use different land uses on sub-watersheds and how those were affecting water quality. They did use some of these, some of the data from these forested watersheds at Quabbin. They also looked at a heavily urbanized watershed and I think an agricultural watershed. From what I remember, the forested watersheds were, very clean. Basically, there was very little nutrient export from the forested watersheds, especially in comparison to the urban and the agricultural. Beyond that, I think you'd have to just look at the literature, which is there's quite a bit of it out there, looking at forestry and forest cover changes and nutrient exports.
Okay, great, thank you.
Brian, I have a question that was submitted to me previously that maybe you can shed some light on it. The question was, it is known that removing trees cause an increase in water yield due to the lack of evapotranspiration. Have you noticed a size threshold for a harvest or scale in terms of the proportion of the entire watershed that causes a measurable change in water levels in either streams or the reservoir?
We haven't noticed that, but we're relying on the literature. Especially, I have a pretty good synthesis of the literature here, put together by Paul Barden, Avril de Cortez out of UMass, talking about land use effects and stream flow. Their synthesis points to that threshold of about 25 to 30% of forest stocking removal before you'll see. I mean, there's certainly a minimal amount, but it really starts to ramp up in effect once you hit that threshold. We're looking at, in our paired watershed study, we're looking at a typical approach where we're unlikely to actually hit that level of stocking removal in any one sub-watershed. So I think it's probably going to end up being more on the lines of 20%. And that's typical for what we do. We're not in there removing all the stocking in large patches. It might look large to, if you're standing in the middle of a small cut, but on a watershed wide scale, it's definitely below those thresholds. So that's the best we have. And we're gathering the data to try and make that case.
How about threshold size for like changes in water chemistry? And if so, what type of chemistry changes occur, and how long do they last?
I think it's going to be about the same. I mean,
I think
this stuff is coming out of Hubbard Brook, where they were doing some pretty extreme stuff as far as removing all vegetation, killing it all. That's when you start to see some real spikes in nutrient exports. We would probably get minor stuff here. More likely, it would be. On an annual basis, you might see some, but you might see a little bit more during storm events. I think dry weather, water quality should not be affected by the levels that we're doing.
Okay. Let's see.
I have
Sandra,
another question, Brian. And maybe this was in the presentation, either the early part and maybe even Dan spoke about it. Do you have a rough estimate on what you gave a percentage of the watershed, but without me doing the math, like what is your overall harvest acreage for the combined different treatments, managed areas? How many acres on average do you manage a year?
Well, we generally propose work in larger blocks than we actually we do work, and I can give you some estimates of the amount of material we're removing. It averages about let's see, it's under 2 million board feet, 2,700 cords of fuel wood, and about 4,000 tons of pulpwood. That's division wide. So the amount of acres, you could do the math, but if we're looking to regenerate about, I would say 400 to 500 acres per year. we're working in areas larger than that, because we're not just removing, and making regeneration patches, removing canopy, but we're doing some tending, some intermediate work in between. So anyway, it's probably on the order of about 3 to 4 times the amount that we're regenerating each year. So yeah, I don't have the numbers in my hand, but it's something like that. We're looking at a 1% regeneration, and we're only hitting maybe half of that per year. So,
Okay, that's helpful. Yeah.
Are you folks aware of the AG's presentation that was just given this past Tuesday? I would highly recommend you watching it, because a lot of what was mentioned today runs counter to what the AG's, and this is the Massachusetts Attorney General's office, announced this past week.
I'm not familiar with that.
Do you have an email? We'll be glad to send it to you folks. It's very important for our future. Thank you.
Brian, I got one last question that was also posed about, have you guys looked at any groundwater changes within the harvest area? Is it, with the reduced tree cover, is there more or less available groundwater within that harvest area, and how does that affect future plant growth?
I think there have been some university researchers who have set up studies in the past. Something that we did internally. But yeah, I mean, I think you can extrapolate from known science on the effects of removing tree cover, changes in evapotranspiration rates, availability of groundwater, changes in temperature, especially in these little patches. The larger the patch, the more significant the change. The more well, I won't extrapolate any more than that. But yeah, I don't have that data, and I think there's probably studies that have been done at Quabbin. I just don't. I don't have them, in my head to tell you about them. Sorry.
I've also been reading that there's significant problems with that weather changes happen from removal of trees, like in the rainforest that's going on. Scientists are finding that it threatens the climate because the trees really help keep the climate in balance.
No doubt, there's, trees certainly, remove carbon dioxide and create oxygen, and we know this. And if you've got an unsustainable approach to using natural resources, that's certainly going to bring the climate out of balance. We don't think we're guilty of that with the level of management and the style of management we're doing here on these water supply lands. Dan, you can add anything you'd like to that.
Yeah, I think that's the Amazon or the tropical, that's an extreme example. You're right. I think in a lot of cases, they're cutting down the trees and converting the land to something else. So keep in mind, everything we're doing, it's always forest land. So we're changing, the age and the height and the species of trees, but there are always trees out there. So I think that's an important distinction to make with what we're doing.
So in the chat box is the AG's presentation, and you will hear some of the recent science that talks about, although you're keeping it as forested land, the forests are taking much longer to rejuvenate. And now the estimate is that when you remove a mature forest, it's taking as much as 120 to 140 years for you to regain, if you will, the carbon sequestration efforts of those maturing forests. And I would encourage this panel to look at Nathan Stevenson's work and Bill Mamau's work with Susan Massino, and to really take a look at some of the impacts long term. And one of the questions I'd like to ask the panel is, are you doing environmental impact studies prior to any of the commercial logging that you mentioned that is happening in the Quabbin, in looking at the species that are there, the soil composition, you know, things of that nature.
Well, I think Brian did touch on this, that we have a vigorous internal review. So we do look at our proposed forestry lots from a lot of different disciplines. So we just don't go out there, pick a spot, and then proceed with, you know, marking trees and harvesting. We have a very strenuous review. So yes, people are looking at wildlife aspects. People are looking at cultural resource aspects. People are looking at environmental quality aspects. So I think we do a good job sort of making sure that what we're proposing is, you know, something that's sustainable and workable. And again, and the public has opportunities to provide input in this process as well.
Have you analyzed and disclosed the climate impacts from your industrial logging program within the Quabbin? And have you done an analysis that shows your 1990 levels of greenhouse gas emissions and how your logging activities are reducing your greenhouse gas emissions on an annual basis compared to the 1990 levels?
No, we don't. We don't have that data.
Hey folks, I hate to cut this short, but over time and got to run to our next conference sessions. I want to thank the presenters. You know, great work. I think it's often misunderstood work, but I think you folks are doing a great job, and you know, keep it up. And you know, thanks for informing all of us on the line. I'll be sure to send out contact info, and the PowerPoints will be made available, so folks will get that, and let's keep the conversation going. Okay, so with that, take care, and thanks again.
Thank you.
Thank you.
Thank you, everybody.